sorry, I will continue in English. My dialect is sad. So first of all, who am I? I'm Aurélien Hebért, and I currently work at OVH. So the place you see at the first screen is my living room in Brest, and there is sun and sea, so it's great. And I also work on the OVH Metrics platform, which is basically the monitoring platform for OVH, all our servers and applications, and also a public open service. And by night, I also give an hand to everything that can help other developers like local segments and also for other associations locally. So today we are living in a world that is getting more and more connected with more and more devices. And all those devices are producing data. But as we are growing, then also a lot of stuff that are going on those devices as we want to know a lot of more stuff and we want to gain a lot of knowledge of our devices. So on a daily basis we are producing more and more data every day. And we need to be able to classify them. So I think many of you know the relational models, as it's quite a famous one, but there is a lot of other ways to classify our data. From the key value store, document store, graph store, and other. But when we are talking about server and application data, are they really relational data, or are there something else? When I have my server, and for example, when I have failure, I want not to know only the current time of data. I want to know what happened before, so I get notified with it. But I want also, for example, sometimes I have problems, so we fix it, but I want to investigate why we had this issue. So we have to collect not only one point, but several points that are indexed in time. And we call them metrics or time series data. We are lucky the time series data are well known because, for example, in financial system, this is what they use, and they build a lot of tools to analyze time series data, and they have a lot of money, so there are a lot of available research on how to analyze this kind of series data. But how do we store them? A lot of time series databases exist, and a lot of them are open source. So we have a choice about, I can name like 13 of them. I won't try to list them and to compare all of them. I just don't have the time. We can talk like for hours about all of them. But if you want someone who made a great job to compare all of them, the 31, not only the top 10, started at the top 10, but then you get like a lot of details on scalability, on how they encode data, on the query capacities of all open source time series, of a lot of open source time series. So you made a great job, and you can search on Google and find its comparisons. I will talk in this talk about how to query my time series data that I've stored. And I will take the example that is my field and where I currently work for, the monitoring use case, how to monitor servers. And on the servers, you already have a lot of metrics to tell that the server is well alive, from the disk informations to temperature, to CPUs, to memory, and so on. But what want we to do with this kind of data? We want to gain knowledge, we want to visualize them first. And for the other use case, when you don't only want to visualize, you will add some analytics, and we will see how some time series databases are offering you the capacities to do analytics directly on the data. And I will also talk about a lot more complex use case, that is the quest to exoplanets on time series data. Let's start with a real example. So let's take my single servers and let's collect, for example, 3 different metrics. So I will only take the memory available, the CPU usage, and the disk I/O. And so I set up on my server an agent, which is called Telegraph, which is widely known. And this agent is useful to collect a lot of server data and a lot of application data, as we have a lot of connectors existing. So basically, what my raw data looks like. So you can see here, you have the time series name, the matrix name, which is the memory available. You also get a lot of metadata, as you have basically the host on which the agent is running. And here I collected the agent name, which is Telegraph. But we recorded some measurement with the time and the value associated. So like this, it's not really like we can't tell anything. So we have to visualize it to learn something. So in this demo, I will use the Graphite tool to visualize the data, and I will use 3 time series database. I don't know if you know them, if you are familiar with some of them. So first of all, just let's plot them. With OpenTSDB, it's quite easy to plot data. You just have to send a JSON, and with Graphite, the start and end time parameter are already set, so you already have just to set the metrics, and with no aggregator to get the raw data. With Prometheus, it's easy too. You just have to put your series, and the start and end are already set. You just have to choose the step parameter. We will see why later on. And with Graphite, it was also easy to just plot the raw data. But as soon as I get more data for a single server, sometimes I have several CPUs. So I have a lot of metrics, and what if I want to already reduce a bit of my data to see a little bit more clear? So first of all, in time series, we often start to reduce vertical. Oh, sorry. I should have pushed one button, but sorry. Perfect. Thank you so much. So when you will want to work with time series, you will want first, for example, if you are loading a lot of data, you will want to reduce vertically time series. And you will want to have one point, for example, every 2 minutes. Let's take an example. This way of doing it for a time series is called a sampling operation. So here I have my raw data, and I will cut them in a period of 2 minutes, where I will apply the operations and keep only a single point. And I will process it, my whole series, to get a reduced amount of points per series. With OpenTSDB, it's natively done with a downsample parameter, where I can put, for example, 2-minute average, but we could have used any other time operation, like for example, 4 or 3 minutes, and a lot of operators are existing for OpenTSDB. So for example, we can choose average, count, standard deviation, first point, last point, percentile, and so on. With PromQL, you can only choose the time. You can't choose the operator. Here, it's done with a step parameter. And this is what is the step parameters done for. It's to keep only 1 point every 2 minutes. So when we query your Prometheus database with the step, you will get only 1 point every step parameter. And you have no choice of the aggregator. In each window, it takes only the last point. So it depends really on what you want to do with the data. But it's already a first limitation of the PromQL query. With Graphite, you can't really do it, as in fact, it's done at ingest time. So Graphite, you push your data point, and it will compute an aggregation based on your configuration rules. At configuration, you can choose the duration, and you can choose your function you want to use onto the sampling operation. So now I have reduced my data points on my CPU. So it's a little bit more lean on my graphs, so I can start to learn more about my data. But now, for example, if I have several hosts for an application, I may want only one series for the CPU and for the CPU measurement. So what I will do is that I will regroup my data. But we sample the data before, and it's great because it allows us to align the ticks between all the series. It means that we can compute, when we will start compute the navigation, we already have the point at the same time, which is one of the biggest story of when you are computing time series analytics. It's why my data are not aligned and when it's not done already. And how can I do it? So sample your data and then process your reduce. So for example, with OpenTSDB, I just put an aggregator and my ensemble, and it's done. I have the max value of 2-minute average. So every 2 minutes, I have the max value that of each CPU's average of 10 minutes. And with OpenTSDB, you have a lot of operators to aggregate your data. What is different between two aggregators? For example, if you see min-max and max, is how you will interpolate missing values. Because you can have series that didn't record it value between 4, 5, or 10 minutes. And so, with max, it will interpolate the missing data point. So it will take the point before and the point after, and it will compute a values average in between. With min-max, for example, it will take the minimal value and it will put it. So instead, if you have another series which are above this one, you won't notice it. So it depends of your use case and which operator you want to use. For PromQL, you also can just put an aggregator instead of in front of your query, and you have the choice between a lot of available operators from summing the series, average, and so on. And with Graphite, you have the aggregate functions that allow you to apply an aggregation on your series, and you can choose as parameters the function you want to apply on all your series. And you also have a choice between a lot of aggregators. So that way, we were able to see the data. For some use case, it's enough, so you already got your CPU, but it's not always the case. For example, if I just plug my disk I/O, well, I see that the data is increasing, but I really can't tell if there is something happening on my system. So I have to add some analytics on my data. In the second part, we will see how those time series have integrated the analytics part. So from the disk I/O I have, I want to transform it into a weight. So I can see in real time what are the weight, the disk I/O weight on my data. So I came with bytes, and I now with byte per second. So doing it in OpenTSDB is simple, as you can work with counter data, and you can just add the weight option on the OpenTSDB queries. But that's the limits of OpenTSDB. You have no further function that will allow you to manipulate the data. And when you are using Prom, you directly have the weight function, but you have way more possibility. As we can do, for example, a sort of your data. You can compute data, you can compute square root, you can compute window function on, to do moving average, for example. Graphite has a lot of function, and you can do a weight with some of them for that function. So for example here, I just applied series divisions, and on the derivative value per my term of sampling. But I have also way more functions than are available in Prometheus. And now I have the second series, which are the time taken by the disk I/O. So what I wanted to do is a simple operation that is a division between time and disk I/O rights. So with Prom and with Graphite, it was quite simple to do it. So at the end, what was the conclusion I can do on the queries part between Graphite and PromQL? So for common usage, they make the time series queries really more simpler, and we had a lot of same functionalities that are available in both. The main difference in the structure, as Graphite is more old than Prometheus, and you have a key value map for Prometheus, so it's more easy to expect so it's more easy to see the labels of your data, so the metadata associated to the time series, when with Graphite it's tags that appears later on. So at the end, PromQL has a more structured and easier way to compute multiple series operation. When with Graphite, you include more time series single operation from statistical, mathematical, and graph functions. So further on, I mentioned a little bit more complex analytics, but for this case, I used another time series database. So I worked formerly in a startup that developed WarpScript, which was an open source, which is an open source time series database. So the queries look a little bit more complex, but for a complex use case, it was very appropriate. And with some friends, we wanted to detect exoplanets on the NASA dataset. And so we took the data of one star, we clean it, and we compute sometimes a series operation to detect a little bit there. And at the end, we were able to get the result that we have here. So what we can see is that we see drops on the data. This might correspond to existing exoplanets. And we did it in WarpScript, which brings a dedicated time series language and really a time series workflow, where you are moving the data on other operations. What it brings also is a lot of query complexity, and you can't use it for end user as you have to abstract it before and to use it. Right. As soon as I'm talking that I work with time series, a lot of people are asking, oh, so you are using Elasticsearch. So what about the Elasticsearch to manipulate time series data? So first of all, you need the Elastic Stack. So you need to set up all of it. So Elasticsearch, then your Kibana and your Tamarian plugin to manipulate your time series data. And then to query time series, it's a query that is similar to the one wanted on the board. And so Elastic does the job at a price that you need the Elasticsearch. But if you already have it, you can use it to mix visualization in your data. And you can analyze multiple series, and you have a lot of native functions. But as in Prometheus, you get less control on how you sample your data, and you need the timeline to analyze efficiently those data. But I also have a question: how will you manage your multiple index when you want to query some historical data? And if you are really a huge fan of Elasticsearch queries, the Uber engineering team released in open source the M3 time series DBs. So I didn't have time to test all the queries possibilities, but if you are interested, have a look, it looks like really nice. So as we can see, there is a lot of possibilities and different time series, different cases. Wait. I'm not missing one of them. Why did I not talk about InfluxDB? Who doesn't know InfluxDB here? No one? Because they first started to have their first InfluxQL for to call queries data. So they wanted to do something that was familiar to people that were using relational data to query the data. What they are doing there was, because they learned that time series data are not relational data. And they found a lot of limitation in implementing it as soon as they wanted it to be able to query use cases. So you can check their blog post. I'm telling you. And they start to develop a new language. At first it was called EFQL. So it was like a time series API with a more consistent semantics. And today, they release at the end Flux. So Flux is a new query language InfluxDB is building. Flux is a data language which will use a lot of native functions to manipulate time series, of course, and you can also use it to build your own function. So how does it work? So we select a data source, which is, for example, the telegraphs data source, and then we filter the data. We want the data which has a measurement called CPU, and then the user system frame. And then we want the last 12 hours of history data grouped by the host metadata label. And we do a sampling on 2 minutes window, and we take the max. And then we aggregate all the data to take the maximal value. So we are doing similar queries as the one we were doing in the demo. So why a time series query data language? First, it's great because we compute your algorithm locally on your data. So you will improve your performances instead of using, for example, Python or R to analyze the time series data. But it's not the only quality of Flux. Flux can come as a proxy in front of another time series database. So you can have the same language used to query other data. And for example, we can connect Flux to Prometheus, but also us to a long-time storage metrics quite easily. We only had to implement a from function in which we specify the from parameters, and then we say that how we want it to keep the range on your data, and we want also how we will connect to the database and fetch the data. And then you can use it instead of the from Influx. So for example, for now, it's only a pull request made on the Flux database, so you can do your +1 if you wanted to add it on the database. But basically, you can do this query to load the data, and then you can manipulate them using the Flux syntax. So us, at OVH, we were also thinking about why not building a time series language, and we were what people want to do with their data. So they want to access them quickly, they want native features, so they just do the job, and they wanted, for example, for Flux sale, that you can use it instead for all kind of backend, you can use the same queries to simplify your experience of data. So at OVH, we had 3 protocols implemented, and internally, OpenTSDB has a lot of success because the query was simple. PromQL not that much, because for really complex queries, WarpScript was better, and so people could solve a lot of more problems. So they prefer to do a lot of more analytics with WarpScript. But the learning curve was really, really complex. So we wanted something that can help them to learn how to manipulate time series and to do a little bit more complex time series queries. And that's what we define TSL as how to make it simpler for developer to query a time series DB. So it started first as a spec, and then we implement a proxy to query data on Prometheus and OVH metrics, the WarpScript platform. And a simple TSL query looks like this. From a select to get your data. So I want, for example, my CPU usage system metrics, where I want only the CPU from 0 to 7. I want the last 12 hours. And I want to apply a sampling operation of 5 minutes. And I want to aggregate them with an average value. And then I want to apply a rate function on it. So it's really a data flow, a time series data flow. But we wanted also people that were more experienced to be able to do a lot more queries. So we had to add some more complex case where the people can use TSL and declare variables and declare use time series operators, and also a lot of framework functions as window functions or filter function and transform the metrics. And we also saw the isopanel case in TSL, and it's only a few lines that I can put it on the slide. So what do we do here? We take our data, we cleanse them, and we sample them, and we store it in a variable. And then we compute a trend from this variable, and then we just subtract the raw data from the trend, and we get the data, and then we just have to apply a threshold, for example, to detect drops on the data. So of course, TSL is open source on OVH, and you can also set up a data source for TSL. So thank you all for listening, and it's only the time series field is like still not full of surprises, and it's only the start. There is a lot of stuff to come.